Thank you everyone for joining for our first Pulsar Summit. And thanks for joining my session on interactive querying of streams using Apache Pulsar. Just a little bit about me. I am an engineer at Splunk. I was originally at Streamlio, kind of the original developers of Pulsar. And then we got recently, or not so recently, purchased by Splunk. I'm also a committer and PMC member at Pulsar, Heron, and Storm. So before we get into the presentation, I guess I would like to first just briefly define some terms. Everybody is probably very familiar with these. What is a stream? It's a continuous flow of data. Almost all data, I would say, more or less originate in this form. And when I talk about interactive querying of streams, I mean querying of both the latest and historical data. Let me actually also share my video here so everyone can see me. Oh, doesn't want to do that, whatever. So for today's agenda, I would first like to kind of go over some of the general use cases of how querying of streams, both recent and historical, are useful. I would then go over some of the existing architectures of what I see commonly used to perform such workflows. I would after give an overview of Apache Pulsar to kind of show how we've designed why, to show that certain features in Apache Pulsar that are there originally and we have put in really facilitate us building a query layer on top of Apache Pulsar. I will then talk more in detail about Pulsar SQL, the internals and kind of how users interact with it. I will then number 5, I will talk about a concrete use case that at zhaoping.com, they're actually using Pulsar SQL in production. So I'll briefly go over what they're doing. I'll also give a demo towards the end, and we can have questions in the last portion of the talk. So let me first talk about how it's useful to query both recent streams as well as historical streams, as you would say, is speed. Because you can do both, you can potentially act faster on basically certain tasks and certain signals. Accuracy in many contexts, like wrong decisions may be made if you don't have the visibility of your current data. So that's kind of one of the benefits of not only querying your historical data, but also your very recent data as well. So as an example, like historical data is useful to predict a user that's interested in buying a particular item. But if my analytics don't also know that the user already recently purchased an item, I might be making some wrong recommendations to the user. Also simplification. So why Pulsar SQL is kind of meaningful and helps simplify people's architecture is that if you're going to only Apache Pulsar for your data, you have one place to access both your current and historical data. Just to go over some general use cases, a lot of what I see people try out Pulsar SQL or similar systems is debugging, errors and exceptions, troubleshooting systems logs. Have I seen this error before? And basically correlating errors with potential root causes. Another is monitoring. This has kind of a security aspect to it. Is by looking at logs or some other kind of data set, I can answer questions of what happened, when something happened, who triggered this thing to happen and why it happened, and from there detect kind of suspicious access patterns. One example for this would be auditing CDC logs in financial institutions to make sure there isn't any shady business going on. Another very useful use case, especially in terms for Pulsar, is just exploring your data. Right, currently it's without this kind of querying layer, like it's a lot more difficult to see what I have in my topics, and to basically look at the data, not just the latest messages, but also the historical or not so new messages that are already in my topic. So this querying layer allows users to kind of look at a topic in a more holistic manner to see both the new stuff as well as the old stuff. There's lots of use cases for this, as you would imagine, like data analytics, business intelligence. Another really popular one is just dashboards. I can I'll demo some of this later, is just to have dashboards to see what is in my topics and do some analytics around that. So next, I want to kind of talk about the existing patterns people have been using for stream processing and kind of stream analytics. A lot of architectures kind of follow this general workflow of I have data ingestion, I come to my message bus, in which the message bus may be storing this data either as part of the message bus or in Pulsar's case in its own storage layer, but it's storing the data somewhere, and then from there messages are consumed from the kind of compute portion or layer of the architecture, in which it's processed. The results may be dumped into the storage layer again, and then from there you either can serve the data out of storage layer or do some querying and so on and so forth. The kind of existing to kind of actual realize that kind of that workflow, I see a lot of I commonly see a lot of various technologies being used. For example, in the messaging layer, I see Pulsar, obviously, Apache Kafka, very popular one, Amazon Kinesis, and Google PubSub. For the real-time compute, there's all sorts of stream processing engines out there as well. Storm, Flink, Heron, just to list a couple that will basically read from a message bus, and then often it dumps results into some sort of storage layer in which you can have this would be like HDFS, S3, Google Cloud Storage, or any other distributed file system or object store, and then you have traditionally MapReduce query that storage layer, Apache Spark or Presto to basically query your storage layer, which often people also describe as your data warehousing or your data lake that you're having these other basically data warehousing platforms query. So just to identify some of the complexities and problems with the existing solution, right? As many people can see, there are multiple systems in play when basically implementing such a workflow. It's not necessarily a bad thing, but there's definitely a lot more overhead in terms of management of those various systems, as well as acquiring the technique, the expertise to basically deploy and manage those systems in production, right? Another problem is, as you probably realize, there's a duplication of data. Some of your data is going to be, your more recent data is likely to exist only in your message bus, while the older data is stored in your basically your data lake, data warehousing layer. So there could be some data inconsistency, and a lot of times when you have faults and you're basically replaying stuff, there is a problem of where is the source of truth, right? Like, is it in my data warehousing layer? Is it in my kind of message bus in my streaming layer? Like, you don't know, right? That's why this whole idea of Lambda architecture, that I won't get into, came to be because of issues like this. And the last point is, there's a latency between data ingestion and when data is queryable, right? It takes time to go through the whole the streaming layer, including your message bus and your stream processing engine before it gets written to your data lake, and then it becomes queryable, right? Like, there's definitely, it's not instantaneous. There's definitely some latency there that to some users might be a problem. So this is kind of where Apache Pulsar and Pulsar SQL comes in and really shines, is to kind of address those above problems I've mentioned. So I want to briefly talk about, like, Apache Pulsar is traditionally viewed as, we would describe it as a flexible messaging and streaming system backed by a durable log storage. So what that really, what in people's mind really, that gives a picture of is, Apache Pulsar is a message bus, right? I publish messages and I consume messages from, a topic or a channel, and that's it, right? I think as, we go along in the evolution of kind of streaming solutions, as well as kind of looking into the other use cases that Apache Pulsar might also provide solutions for, we can perhaps also think Apache Pulsar as an event store, right? And I'll talk about kind of the features and core architecture concepts that really allow Apache Pulsar to be an efficient event store. But for those that are not familiar, event store is basically another idea of storing your events or streams, right? And at this diagram kind of provides a glimpse of what I'm going to talk about a little later. That messages can, well, producers can produce structured messages or a structured stream in which there's a schema, right, to a certain topic or channel, and that schema is basically labeled for a certain, as assigned, mapped to a certain topic or channel. And because of that, because now the data within a topic is structured, it allows us to kind of query the data using kind of a SQL-like language to basically examine what is inside. I will now give an overview of Apache Pulsar, and I really kind of, I guess like most people probably are familiar with Apache Pulsar, and has been various talks about the kind of architecture of Apache Pulsar. But for my portion, I really want to emphasize why certain aspects of Apache Pulsar's architecture, as well as certain features, really make sense for us to build a query layer, an efficient query layer on top of Apache Pulsar. As many of you probably are aware of, this diagram provides a kind of an overview of the architecture of Pulsar. Pulsar has a multi-layer architecture in which kind of the messaging or compute portion is separated from the storage. So this has many benefits. I won't go into all of them, but in terms for SQL, and basically storing data, and Apache Pulsar being an event store allows storage to be dynamically scaled out transparently and also cheaply versus kind of other platforms. So I think the more important concept here that allows our Apache Pulsar storage layer to be dynamically scalable and transparently, and to scale transparently to the end user, is because of the idea of segment-centric storage. So instead of basically storing whole partitions or topics as just files within a broker somewhere, a single topic is divided up into various logical segments or ledgers in Bookkeeper, and they're basically sprayed across all the Bookie nodes in a way to basically balance not only storage but also I/O and network throughput. So what this means for basically a storage engine and Pulsar SQL, the layer we built on top of Pulsar, is that it allows us the SQL engine to read multiple copies of a segment in parallel, or allows the SQL engine to read different segments of a topic in parallel to really leverage to maximize the disk I/O as well as the bandwidth of multiple machines, instead of basically using kind of, if you think the naive way of just the SQL engine using a consumer to read out all of the data from a single broker. So this is one of kind of the key aspects that really make building a SQL layer on top of Pulsar feasible and efficient, is because of the way Pulsar stores data in its storage layer, and to be honest, and the existence of the storage layer makes all of this Pulsar as an event storage platform and a query, and also to build a query engine on top of it. It makes all this kind of make sense. So another kind of aspect is how we're basically writing data into the storage layer. So when you configure a namespace in Pulsar that basically assigns policies to underlying topics in that namespace, you can determine how many replicas you write, right? So by default, there is a number, I think it's 2, that is set to 2, which means that 2 replicas are written to the storage layer. But that number is configurable, and there's basically implications there that you can leverage if you're basically wanting to also query the data in the storage layer as well. as you can imagine, if you increase kind of the number of replicas for a specific topic or a set of topics, and there's more replicas there, sure, you might pay the cost of more storage, but when you're reading them out, you can leverage more bookies or more machines and achieve higher read throughput when especially your SQL query or the SQL engine is reading the data. So these things are configurable, and these are knobs that the user, the end user can configure to basically, tune these trade-offs for their use cases. And another thing that kind of another part of Pulsar, but more specifically Bookkeeper, that really benefits building a SQL engine on top of Pulsar is the fact that Apache Bookkeeper really kind of resembles the traditional architecture of a database in terms of how it's supporting reads and writes, and more specifically, a lot of the type of workflows that SQL engine will do is these, basically scanning the data right across the whole topic, or at least a range of data. So Bookkeeper has a concept of a read ahead log, in which basically if the SQL engine or just a reader in general decides to, I want to start reading from this point, it will preload a whole bunch of entries as entries, which are basically individual items within a segment or a ledger, preload them into database. So we essentially taking advantage of the concept of sequential reads, which allows us to improve basically the read performance of the underlying hardware. And like I said, a lot of the times we're scanning through data. So if we're going to read entry 1, we're likely going to read entry 2, 3, 4, 5, and 6, right? So this kind of preloading into memory allows Bookkeeper to really support these high throughput reads that a query engine really needs. Another interesting concept, or a feature that was added a while back is tiered storage, right? Because of Pulsar segment-based architecture, it's very easy, as you would imagine, to just offload some of the segments into another layer of storage, like S3, Google Cloud Storage, HDFS, or really anywhere, right? To basically kind of achieve to really have, I would say, a cloud native architecture, and to achieve this concept of really unlimited storage capacity. So what this kind of means for Pulsar SQL is not only can you query the data within the Pulsar storage layer or the bookies, but it can also query the data offloaded into kind of an object store. So this is powerful in many ways, because the concept of tiered storage is often used in which you have hot data, maybe more recent data in your bookies, while you have more older data in your tiered storage or in kind of your object store in the cloud. And with Pulsar SQL, it's transparent to the end user. It doesn't matter where this data is; it's able to query it, no matter if it's in the bookies or if it's offloaded into some cloud storage. And I touched up on this a little earlier. Is users can now produce data into kind of this has been a feature for a while. A user can produce data that is structured into Apache into a topic. What this means is that we have basically a schema assigned to a topic, and we built a schema registry to kind of assign and check whether data is of the right schema before entering a topic. So this essentially allows topics in Apache Pulsar to be structured, right? And we kind of really, in order to query kind of data with a SQL-like language, you really need to have some sort of structure in your data, so that the SQL language can interpret the commands and return the relevant the set of data to you, right? And for our schema registry, we support JSON, Avro, and protobuf. So it doesn't really matter which one of these schema or serialization kind of methods that you use. Pulsar SQL will be able to read out that data appropriately. So you can imagine I have some data and written to a topic in JSON, and there's obviously a schema attached to it. Some data is written in Avro. I can query both of them using Pulsar SQL, and it doesn't it's transparent to the end user what exactly the coding is for the data underneath. So now I'll talk a little bit more detail on Pulsar SQL and kind of the internals of how it actually works. So Pulsar SQL, the current implementation is really based on Presto, and it leverages the Presto SQL engine that was originally developed by Facebook, and there's a whole community around Presto. So the reason why we decided to use Presto is it has a fairly straightforward integration. Writing basically a connector for Presto to read data out of Pulsar is fairly straightforward, and there's a fairly strong community around Presto. I mean, you can arguably say that we can perhaps use Spark or even Flink to do the same thing. Sure, that's I think there are other talks given today that discuss the possibility of doing such things, but our current implementation is based on Presto, and Presto has some good performance characteristics that we've been leveraging as well. And also, there's generally a lot of people use Presto to do these kind of things. So you can imagine that I can have one of my commands queries my Pulsar cluster, as well as joining the data from data that I have in S3, and that's all possible because of the various connectors that Presto offers. So what we've essentially done here at the core is built efficient Pulsar connector for Presto. So how the general workflow for it works is we read, instead of reading data from using a consumer or a reader in which the data is served from the broker, we read the data directly from Bookkeeper by bypassing the Pulsar broker altogether to maximize our throughput. So what we really need the brokers for, we still have to basically use the brokers for acquiring the metadata and involved for basically identifying the ranges or the ledgers involved for a topic. So all we're doing, so the connector will need to communicate with the broker to fetch the metadata, but for the actual reading of the data, we're going directly to Bookkeeper and fetching the data in parallel. As I touched up before, because of the segment-based architecture of Pulsar and using basically writing data from a topic as segments or ledgers and Bookkeeper, we can have these many-to-many reads in which multiple workers can read data in parallel from Bookkeeper, even though it's a single partition, right? So we're not, in this case, not even limited by any sort of constraints for a single partition, at least as long as the partition is kind of replicated in a reasonable manner across bookies and machines. We can basically leverage the I/O bandwidth, and also leverage the disk bandwidth, the disk I/O bandwidth, as well as the network bandwidth to basically read that data out. Another thing we support is time-based indexing. So you can think of it as a predicate pushdown, from Presto onto Pulsar. The reason we can do that is because how we write ledgers into Bookkeeper are naturally ordered by publish time. Thus, it's very simple for us to, if you give us a predicate of where between the publish time between A and B, we can basically we're able to go to those points in time and basically start reading the data from A only to B and deliver that to Presto. So basically it minimizes kind of the amount of data we need to fetch for the topic that you're reading. And here is kind of the general architecture, provides a general architecture of Pulsar, as well as, kind of the SQL layer that we've built. As I said before, producers and consumers can be writing data into a broker. The broker will then write these segments out to the bookies, and then you have another layer, abstracted as the SQL worker layer that will be basically, directly reading data from this bookie, from the bookie. But the coordinator will be fetching kind of the topic metadata from the brokers. As I mentioned before, basically the starting and ending points, and kind of the storage layer, where each worker kind of will start and end reading. So the query coordinator is also kind of responsible for distributing or splitting the data across the various SQL workers, so that a lot of this work can be done in parallel. So for example, if I'm reading from one topic, message 1 to 10 might be assigned to SQL worker 1, 11 to 20 might be assigned to SQL worker 2, and so on and so forth. And basically then the worker will go and basically read that data, from that portion of data from the bookies. And this is kind of the theme across this whole design of Pulsar SQL is really leveraging kind of the idea of reading things or doing things in parallel to maximize kind of scalability as well as performance. And I forgot to mention, but this is the same idea with if some data is offloaded into kind of tiered storage, a SQL worker can transparently also just read that out from S3, Google Cloud Storage, or so on and so forth. So kind of the benefits, right? I touched up on some of the problems of or complications of existing designs. So just to bring it back around, with Pulsar SQL, you don't really need to move the data into another system for querying, right? I don't need to dump it into a data lake and then allow Hadoop or another query engine to basically query what's in my data lake. I can do all of that with basically data within Pulsar, right? I can query the data more or less directly. And because of Pulsar's architecture, we're able to read the data in parallel, and performance is not really impacted by how you kind of partition the actual logical partitioning of topics, right? It depends on it more depends on the number of kind of replicas in the underlying that Pulsar is writing to the underlying Bookkeeper cluster. So like I mentioned before, if you want to kind of play around with that, you can try to increase throughput by increasing the write quorum, but obviously the cost you take there is you'll store the data more times, right? And just to reemphasize that, because we're querying your data within, I would say your message bus, right? Pulsar is still a message bus. Like you can query the data, not only the data that just arrived, but also the data that has been stored and Pulsar as well. So that's all very, very easy to do, I guess, with this Pulsar SQL layer that we've built on top of Pulsar. So I just want to kind of discuss briefly, how this compares with other message buses, right? Pulsar does have other integrations with, other message buses like Kafka, right? But the difference here is, because of the various, differences in architecture of Pulsar versus other message buses, like, a lot of message buses, they don't have a separate layer of storage, right? Your storage and your serving, is all basically condensed into it's condensed into one layer, right? Or one set of nodes. Thus, it's at least right now, it's not super feasible to basically directly read data, directly read data from basically those nodes. Those nodes are those set of nodes without actually just basically standing up on consumer and reading it out kind of in the traditional pub sub manner. But the problem with that is a lot of these, using a consumer to read from a message bus, those workloads are really kind of optimized for latency, while on the reverse side, for a message bus, all we really care about is kind of throughput, right? That we want to be able to read all data out as fast as we can, and we don't really care about per message latency. Thus, you can take a look at the Presto integration for other message buses, but it generally follows the idea of, I'm not really going directly to a storage layer to read. I'm just basically standing up a consumer and reading out the topic, basically, like a regular application. And this causes problems like, if it's a single partition and only one broker can serve a partition, then you're only really kind of blocking yourself or constraining yourself to the network bandwidth and IO bandwidth of a single node. Now that I've kind of given an overview of the architecture of Pulsar SQL, I kind of just wanted to briefly talk about how users can interact with Pulsar SQL, at least on a command line level. So we have all these tools built for Pulsar SQL to allow users to have a user-friendly experience, right? So what's included in the Pulsar package is already a CLI client. So as you can see here, here, let me go back. A user can just basically start up that CLI client, can show catalog, which basically will bring up Presto, a Presto CLI client as well, and you can basically list the catalogs, which is kind of the idea of almost like a cluster in Presto. So if you list the catalogs, you just see Pulsar there. And kind of how we mapped Pulsar terms into kind of Presto terms is, for a schema is basically mapped into the idea of a namespace. So when you do show schemas in Pulsar, you should basically get all of the namespaces that are available to you. So the first one, information schema, that's basically that's always going to be there and provide some basic information about your cluster, and you can feel free to look in there, and it'll give you like information like what is the URL of the cluster and so on and so forth. But the rest of the entries should be basically all the namespaces that the cluster has. And to list the topics, you can say topics. The idea of basically tables are mapped to topics in Presto. So if you do show tables and Pulsar and you provide the namespace, you should be able to see basically all the topics you have in that namespace in Pulsar. This is kind of just to give an example of actually looking at some of the of data that you can when you actually basically do a select star of a topic, it basically lists all the messages in there in a structured table, and you can basically explore the data in that fashion. And I'll also kind of go over this in the demo. So now I kind of want to get to the more interesting part, is actually showing you guys some of this cool stuff. So I have a demo set up right now in which I have this kind of pipeline deployed, in which I have a Twitter fire hose. This basically uses the Pulsar IO Twitter fire hose source. It's going to write retweets from Twitter, write them into a tweet topic. I then have a sentiment analysis function using Pulsar functions deployed, in which it will classify the tweet as a positive tweet, a neutral tweet, or a negative tweet, and then route them to the respective topics. And then I'll basically query that data from Pulsar SQL to explore the data, as well as do some dashboarding to see basically what kind of the sentiment of tweets that people are tweeting right now. So let me exit my presentation here, and I already have the cluster deployed in the cloud, and I'm basically using a tool here called Superset. It's another Apache project that is quite useful and allows for basically a lot of nice dashboarding tools, as well as a nice kind of SQL UI tool as well to basically run your queries. So let me zoom
Very sorry to interrupt really quickly. I just want to give you a heads up that we have about 5 minutes left.
Yep.
And we have some questions in the Q&A function after you're done.
Sounds good. I'll conclude this fairly
No worries. I just wanted to let you know.
Just to kind of show basically what we have going on here is, let me first go to schemas. Basically, if I run this, it'll show basically kind of schemas I have, so on and so forth. And for tables, I can basically say, look, like show my tables in the public default, the default namespace. I can run my queries here, and as you can see, there's basically kind of 4 topics we have: negative tweets, neutral tweets, positive tweets, and basically the raw tweet topic that we're dumping everything in here. And something interesting like, let's just count the tweets and so on and so forth. As you can see, if I do, counting the tweets, the number of tweets, it's increasing. I don't have that many tweets. I just recently started this, but we can basically do a count. It's also interesting. You can describe the table, like I said, and basically it'll give you the schema of the table. And we have, a bunch of kind of, columns for the tweet, as well as internal columns like, partition. Though if this is basically a partition topic, which partition ID is from, if there's an event time assigned to a publish time, that'll be defaultly, filled out for you, as well as, a bunch of other properties, and so on and so forth. So, that's all cool and whatnot. And, just to have some fun, I've also built a dashboard for basically, viewing, basically how many positive tweets I'm getting, neutral tweets and negative tweets, and then also graphing them into a pie chart, right? So, I can refresh this and it'll get the more recent data. So it seems like I'm getting a lot of positive tweets right now. So, you can interpret that as, any way, you want. I guess to give some context on why this is kind of interesting, in a previous job, I worked at a hedge fund, and basically one of the things we did was basically this similar workflow. This would be like a signal fed into a trading system, and based on how people are feeling, whether we should make certain trades or not, right? But, in that context, before Pulsar, like, we used a whole amalgamation of systems just to do something that, as I demonstrated, like you can do just with Apache Pulsar, right? So that's it for my brief demo here, and kind of just to close up and, the rest of my slides here, I kind of want to briefly talk about, performance. We've done some performance testing, and we have, some, and we're going to keep on working on tuning the performance, but we're able to kind of on 3 nodes get around, 60 million rows per second in JSON, and about 15 million rows per second using Avro. And as I'll talk about maybe in the future works, like we have big plans to kind of improve the performance, and so on and so forth. I won't talk too much about this, but I want to kind of talk about briefly how Peng is using Pulsar SQL in production right now. So just to give people a background, Peng is kind of the Chinese website equivalent to like LinkedIn and Indeed.com. Peng was already a heavy user of Apache Pulsar, and basically they're using Pulsar to power their enterprise event bus, and a lot of the data involving position searches, job posts, and resume searches, all dumped into Pulsar. Thus, it kind of makes sense for them to, leverage Pulsar SQL for some of their use cases. So some of their use cases is, kind of can be, broadly fit into the general use cases that I discussed earlier. One of their use cases is debugging search results, right? When search results, aren't what you expected, they want to basically correlate. They want to find out what the issue is, so they have trace ID as kind of a field in their their messages, and they can correlate using Pulsar SQL, like what a job search request is and what the corresponding response is, and by correlating and doing some other debugging, they can kind of figure out what exactly went wrong with the search result, or how the search result isn't optimal. And kind of going off of that, they're also using Pulsar SQL to kind of analyze and improve search results in general. Like, for example, if if someone is if search criteria are associated with a position that a job seeker is applied for, such as when the position was first exposed to the user, and analyzing basically a search criteria, for basically that, job seeker, what that job seeker applied for, they can basically improve some of the quality of their search results. And then last thing has to do more with, kind of dashboarding. They get a lot of search results from different, cities, different locations, and also with different keywords. They like to basically do some dashboarding in which they can visualize kind of where these queries are from, or, what people are really searching for. So they're also using Pulsar SQL for that. And, kind of very obvious reasons why they're using Pulsar SQL is, they're already a heavy user of Pulsar. Pulsar allows, basically queries to use the standard, SQL-like syntax. I don't think it's ANSI SQL, but, most of SQL is supported, and Pulsar SQL can save a lot amount of data, as I brushed up before. They don't have to dump it into some, another storage device and then query it using another kind of platform. They can just directly query it, the data that's already in Pulsar. How to get started? It's quite simple. You can visit the Pulsar Apache Pulsar link and get started there, and it shouldn't take you more than basically 5 minutes to get started. And we've built a lot of tooling around it, so to make basically getting started very simple for users. I want to briefly talk about kind of the future work. We've done a lot of performance tuning as it is, but we are looking to do obviously more performance tuning for this. And we also, kind of a bigger chunk of the performance tuning is explore the idea of how to store the data in a columnar format. So, there's obviously a lot of benefits of storing kind of data in a columnar format in terms of basically querying it using kind of an OLAP use case, like it improves compression ratio, and you only have to materialize relevant columns. So, we're basically exploring the idea of how we can kind of, leverage columnar format and to improve the performance of SQL, how to basically store this data in Pulsar or in, tier storage in S3 in that format, so that, Pulsar SQL can leverage that. And another thing that's interesting that we're going to be looking into is, supporting different indices. Currently, we only have one index, is basically based on publish time, but, we'll be looking forward into if we can index by another time, and, how that would work out in the underlying, storage layer. That's all I had. I guess I'm a little over time, and
No
I
worries.
will, and then we can go in the
Probably
QA.
have time for like a couple minutes before the next session starts.
Sure.
Then any questions that we don't get to, we can jot them down, and then Jerry, maybe you can share some contact information, or they can contact you
Yep.
on the Apache Pulsar Slack channel. Would that work?
Yep. So I've listed my email here. I'm on the Apache Pulsar Slack channel. I'm also on LinkedIn, on Twitter. So feel free to reach out to me there. So to kind of to look at the questions, right?
Yes.
Where Q&A. Okay. So starting from the first one, how does publish time index impact queries using event time and predicates? So currently we're not basically indexed on event time, right? We're only indexed on publish time. So sure, if your event time is very close to your publish time, like there could be, I guess, some optimizations there, but like you have to basically use publish time in order for the connector or Pulsar SQL to detect the predicate pushdown, so that we only fetch basically the data for that range of time. So currently, we don't support event time and predicates. Like likely what would happen is, all of the data will need to be scanned to make sure, to return the correct result to you. But look, like I said, in the future work, it might be one of the things we can look into is, how to index on basically event time as well. Do query coordinator and SQL worker run on the bookies or separate nodes? So they run on separate nodes. So there's basically another, you can use our tooling that we provide in Pulsar SQL to deploy essentially a Presto cluster on the side that will basically query kind of your existing Pulsar cluster. Or you can, if you already have a Presto cluster, you can kind of just drop the connector into your existing Presto cluster, and it will basically, you can query Pulsar that way. But yes, the coordinator and SQL workers run on separate nodes. How do you specify in Presto that you only want the latest version in case of a key value topic? And is also possible to query on a specific point in time. For example, given the latest versions of TPCH orders, or give me all the TPCH orders. Okay, I see what you're saying. So it seems like the question here is more designed for kind of a workflow that's more of an OLTP type of workflow, in which, look, like especially if you have out of order data, you want to update data, update basically your tables and your database to kind of a latest version of the data. and that's kind of not exactly the type of workflow we're targeting. So we're not basically, Presto is kind of, Pulsar SQL is only a read only. We're not basically, writing that data into another database anywhere. And in terms of the different versioning, sure, you can have a different version of basically your message as a specific field, but we don't treat that as nothing more than another field. I guess you can basically orchestrate some queries in which you want to kind of scan through the data and return the SQL query with the latest version of things, but that's kind of we don't do that implicitly in the background. Here, let me go to the next one. Can queries span topics, or if so, how are they fanned out? How is the fan out handled? Right, so queries can span multiple topics. You can basically join, you can join data from one topic or multiple topics together. And at the end of the day, it's the same idea, right? When it actually, gets, the SQL command gets, the SQL statement gets processed by the execution engine, like it'll basically go out and fetch the data from the for the various Pulsar topics. And as I mentioned before, the data, because of our segment-based architecture, can be read in parallel from various Bookkeeper nodes. So at the end of the day, like querying the number of topics isn't necessarily a problem, given that you have enough bandwidth on your storage node, and have tuned the right number of byte quorum to support the basically the load, that the read throughput that you kind of desire for your query.
All right, hey Jerry, I'm actually going to call it there. We have a couple minutes left of even going into the break now. There's still a few questions coming through. I'm sorry we couldn't get to all of them, but I will email the questions to Jerry, or feel free to reach out to Jerry directly. He shared his email contact information, and you can also reach him on the Apache Pulsar Slack channel. So please join that and reach out to Jerry if you have any other questions. Sounds like there was a lot of engagement and it was very informative. So thank you, Jerry.